I'm Darren Croft, I'm staying here at the Centre for Whale Research. I'm from the University of Exeter in the UK.
And I'm Lauren Brent, and I'm also from the University of Exeter.
And we're here working with the Centre for Whale Research, making use of this fantastic long-term database that's been collected since the 70s. And what this has allowed us to do is ask questions about life history, how animals age, when they have their offspring, and at what age they have their offspring. And the 40 years of data that's been collected here has allowed us to track individuals through their lives as they're getting older. And what we're interested in is this phenomenon in humans called menopause. So the fact that in women they switch off reproduction midway through their life but can live for another 30, 40, 50 years. And it came as a great surprise to us that killer whales actually have a similar life history strategy. So females will have their last calf in their 30s or 40s, but may even live on till they're 100. From an evolution perspective, this really generates a puzzle. Why should a female switch off reproduction early in life, when in theory they could continue reproducing until the end of life? And that's certainly what happens in the majority of species. There are only 3 species that we know of where females terminate reproduction early. There's the resident killer whales that are just out here in the water behind us, the short-fin pilot whales, and humans. In humans, it's highly debated as to whether or not menopause is an adaptation, or whether or not this is simply an artifact of us living longer. We have modern medical care, we have modern living conditions, we no longer face predators, parasites, disease have been reduced, and our lifespans have been extended. So is menopause simply an artifact of modern society having a longer lifespan than our ancestors did? The killer whales, in contrast, they're not living longer now. If anything, possibly their lives are more challenged. We've reduced their fish, their primary prey source, there's pollution in the water, yet still these animals are living way beyond the end of reproduction. We're interested in asking the question why. So in humans there are 3 hypotheses. One is that it's mothers helping their offspring, grandmothers helping their grandchildren, or simply an artifact. In the killer whales we can cross off this idea that it's an artifact of modern living conditions, so we can look at whether or not menopause in the killer whales is an evolved adaptation. And we found some really fascinating results so far. What we found is that these old females keep their adult offspring alive, particularly their sons. So in the year following a mother's death, her adult son, up to 30 years old, has an almost 10-fold increased risk of dying in the year after his mother dies. So these old females are doing something that is keeping their adult offspring alive, and by doing so, increasing what in an evolutionary term we call their inclusive fitness, which is by sharing their genes through their sons onto the future generations, particularly their sons. There is a bias in the results towards supporting sons. They form stronger social relationships with their sons, they're together more often. But also when the old female dies, the chance of her adult son dying is almost 10-fold in the year after her death. So she's really doing something to help keep the son alive. It's interesting, this difference in support towards sons and daughters, but if we think about how the society is structured, it makes sense from an evolution perspective. So what's really unusual about these resident killer whales is that sons and daughters don't disperse. So they stay with their mother their entire life, which most mammals, one sex disperses rather than the other. So it's very rare that you get both sexes remaining in the family group. What that means is when a son reproduces, he actually mates with a female from a different group. So the cost of carrying that calf, of raising that calf, is borne by a different matriline, a different pod, a different group of whales. So the cost of sons reproducing to a mother is very small, whereas if a daughter reproduces, the matriline has to care and raise the calf and carry the cost of rearing that calf. So from an evolutionary perspective, we'd actually expect old females, to direct their support to sons, because that's the way they can maximize the transmission of their genes onto the next generation. This left us with a big question. What could it be that these females are doing to keep their sons alive? Again, using the data from the centre, we were able to get at that. I'm going to hand over to Lauren to tell you about that.
Right, so one way that we hypothesized females might be helping all of their offspring all of their relatives is through leadership. So as animals age, they have more experience, just with the fact that they're older, they've been around longer, they have more experience of their environment. So they might have information that other individuals don't have due to this age experience. So one way they can pass this information on is through leading other individuals around. You live in a small family group, you travel together. So if you have information about where and when to find food, in particular, these killer whales are feeding on food that's quite variable, both in space and time. So they eat salmon. It's here in Washington State in the summer months, and the salmon are running up the Pacific into the Fraser River Basin. So understanding, having information on where and when to find those salmon could be potentially really important. So we know these killer whales, when salmon abundance is low, have higher rates of mortality, for example. So salmon is a really important resource to these individuals. So we asked the question, are these older females leading their family groups around the salmon foraging grounds? And what we did using the Center for Whale Research data, there were video clips of the whales traveling through the environment, often which filmed from right around here, right off the shore here. And the center's ability to identify individuals, we were able to say, right, in this video clip of these whales traveling together, this whale's in front and these are the whales that are following. And using those data, we analyzed them statistically, and we found more often than not, old females were out in front. They were leading their family groups. We also looked at who was following these individuals. To have a leader, you have to have followers. And following from the results that Darren was explaining, where we have this differential helping of females towards their sons, we found, okay, everyone's kind of following these older females, but in particular, sons are following their mothers. So this kind of nicely aligns with the fact that these males take a real hit in mortality when their mother dies. Perhaps it's because they are more reliant on her superior knowledge and information about where and when to find food. So it really fits in with what we found previously, but it's also a fascinating result in terms of these individuals, older individuals, having more knowledge and sharing it with their family members by leading them through the environment.
It gives us an insight into our early evolution. If we think about back in time when we didn't have the internet, we didn't have written text, information was stored in individuals. So imagine a situation where a drought occurred that hadn't happened for the last 60 years and we needed to find water, we needed to find food. The knowledge would have been stored in the elders in society, and we'd have gone to those elders to ask them. Now we've got the internet, we've got Google, we ask Google. We no longer really value the elders in society as we would have done, or as our ancestors would have done. Here, by studying the whales, we can start to get insight into perhaps how important that information was in our own early evolution. So by understanding the whales out here, I think we can also get some insight into how we evolved as a species and how menopause evolved in humans. I think the other thing that's really important to stress here is the value of the data that's collected by the Centre for Whale Research. As a scientist, if I developed these ideas, there's simply no way I'd be able to test them in my own academic career. It's taken 40 years to collect this data, and yet we're still learning new things about these whales, and we need more data to be able to continue asking and answering these questions, which are questions that are important about the whales, but also questions that are of fundamental importance for evolutionary biology. And so the continued support towards the Centre for Whale Research is really important, not just for the whales, but also for science as a whole.